Hello, my name is Justin Cena, and I have completed my project regarding determining ideal sites for new highway rest areas. What my project is basically a set of analyses that determine an area where the construction of a new rest stop would be beneficial. Beneficial in that it would be put in place of someplace that has a high density of crashes involving tired, fatigued, and sleeping drivers, and that it would not be in close proximity to an already existing feature. With that density of crashes, the crashes I used were coded with a cause code representing that crash was due to a driver being tired, fatigued, or sleepy, maybe in need of a rest stop, and one was not around. Who knows? And so I took just those crashes that involve that cause code and performed my analysis on just those. And for my proximity, you can kind of see down here I have the circles are the existing rest areas in the state, and the pink boundaries are city limits. And for the proximity, I wanted it to be as far away from cities and existing rest areas as was ideal as it could be. So that's why I put those in there. And so the data that I used, the crash data points and rest area points, I used the highway lines, of course, and just some administrative things like city boundaries, county boundaries. All of my data came from the Oregon Department of Transportation, the ODOT's GIS data portal. And so fortunately, it all has the same projection, Lambert Conformal Conic, North America 83. It was really convenient. I didn't have to do a ton of, reprojecting or anything like that. So in my density analysis, here's a picture of my model. It involves iterating feature selections in order to select highway crashes that and happened on the same highway, and then running densities on each of those if there was more than one, and then clipping those to a buffer of the highway. I'll break that down a little bit. So the iterate feature selection tool, when I first started, I performed the density analysis on just all the crashes in the state, and when I zoomed in and checked it out, I saw that the density was being influenced by crashes from totally separate highways. And to me, that didn't really make a lot of sense. I wanted the density to only be based on crashes of the same highway, and then because then it would say that particular highway has a lot of that type of crash. And so I used this iterate feature selection tool to run through each individual highway so that my model would create a density analysis based on a selection of only same highway crashes. And so once those crashes were selected, I used a select by location. Basically, the select by location was inputting that iteration's highway into select by location and then selecting all the crashes that occurred on that iteration's highway. And if more than one crash was selected, essentially if more than one crash occurred on that highway, then it ran a point density. I found point density to be a little better for like these linear density types. Kernel density was nice, but when I looked side by side, I felt like point density did a better job for this type of spatial relationship, this linear sort of density. I'll explain in my output raster. I'm not sure if you can see my mouse or not, but I incorporated this percent value percent variable, and what that did was it named every iteration's density output and density raster output with a unique name, unique to the iteration, unique to the highway that it pertained to. And so, because the iteration gives you this value output, and you can use that as a variable later on. And so that was kind of nice, because otherwise, if you don't use that, it just names everything the same, or it just overwrites the item over and over again, and you end up with just the last iteration's raster. So once I had all those density rasters, you can see these are the purple smudges. I needed to clip them to the highways. They just didn't look good. They weren't really readable. And so I buffered each highway. My model, you can see here, I buffered each highway and then clipped those output rasters to the highway buffer of that same iteration. And so that gave me this black and white stretch set of rasters. Just a little more readable. It looks more like a road network than just this purple smudginess. The problem with that, though, with doing it this way, is that your output rasters are all going to have a different range of density values. And so in order to use it, you have to mosaic all those rasters together to create one mosaic raster that you can apply a symbology to unanimous to all areas in the raster. And so by mosaicing them, I was able to, put a no display on areas that did not have a high density and a color to those with the higher density. And I just trusted the natural breaks. I played with some of the different classification styles. I just kind of trusted the two-class natural breaks. And so this is an output from that process. This 3-county area is just sort of the area I was using in my trials. Just save processing time, not do the whole state every single time. Also with the density, there's a lot of data grooming on the roads that go into it, which is kind of a problem with this process. Like if I wanted to incorporate it and say, hey, I have this process you can just use, you kind of have to do some work on the roads before you can put them into the models. But you can see here the areas that are in red are the areas of higher density. And so then I had to perform my proximity analysis. And that involves creating points that I considered to be like rest opportunity points. They were where highway meets city edge and existing rest areas. And then performing this path distance tool on that raster to create area, create basically like a rest opportunity desert almost along that path. So first up was creating points where highway intersects city boundary. It's kind of a roundabout way, because when you perform just this intersect between these two types, you can specify point, but it's actually creating your output in multi-point. And if you want to merge features later, like I do, those are considered two different geometry types. So what I had to do was use same as input. It gave me the brighter blue line, which is basically where highway intersects city limit. And then I created, I'd use generate points along lines with a parameter of 100% distance. I don't know how to explain this. Basically, it made lines at the end of those intersection line segments. And it created a line where the city boundary meets the highway line. And that was my point, because once the driver is inside the city limits, I'm sure there's a parking lot or just some place to pull over and just kind of get out and like take a breather and rest and catch a second wind. And so once I had those points and my rest area points, I merged them. You can see here to the right, the one to the far right is an existing rest area, and the other ones are where state highways enter a city. And this part was pretty tricky. I tried a lot of things to try and get this to work, to try and get the proximity analysis to work. At first I was using Euclidean distance, but that was just not good enough. I needed something that had a directional aspect to it. And so what I did was I buffered the highway lines, just like in the density analysis, but then I converted that buffer to a raster using polygon to raster. And what that does is it codes a raster with 1 where the buffer polygon overlaps, and it has no data where the buffer polygon does not overlap. So then with that raster, I can input it into the path distance tool as a cost surface, and no data cells are treated like a boundary in the path distance tool, in that you can't it won't perform the analysis over no data cells. It has to have a 1 or even a 0, but it cannot have no data. It acts as like a wall. And so what that did was constrain my assessment to act, as if it was traveling on the roadway. It found the distances along this network. Here, I'll show you. It did this. So the area in orange is the area furthest from these, these cities. And yeah, and what I liked about it was, while this isn't a network data set, it's just a polyline data set. Using this polygon to raster and then path distance, I was able to, kind of treat it as if it were. And this is kind of the output I got from that. Or it is the output, kind of. But you can see in the red, those are areas that they just don't really have any opportunities. I mean, I'm sure there's some things, there's definitely something between Burns and, whatever, California or Nevada, maybe, who knows. Yeah, I'm a geography major. But anyway, what this does is it doesn't really show you problems. It just kind of shows you areas where there's not existing rest areas, or cities. And city limits doesn't necessarily mean all areas of development. There are many areas that aren't considered cities. So that is one sort of oversight of this project. And then I went on a little side quest. I wanted to replicate this map from ODOT. I really like it. Deer and elk collision density. And I was like, wow, that's so similar to what I'm trying to accomplish. I would like to make the same thing. So, kind of did. There's a couple differences that I'm not going to point out. For the most part, this isn't really spatial analysis. I mean, I guess none of the tools I used belong to the spatial analyst, license set or whatever. It's ultimately just it's just a series of intersecting, splitting, intersecting again, and then splitting, and then you use this spatial join tool. Going back, what spatial join does is, what I put in the crashes and I put in the road segments, all split up, and I divided them between rest areas and cities, and then you use spatial join, and what it does is it creates, if you look to the right, it creates this field called join count, and what that does is it says how many crashes were joined to that segment, and it, so logically that says this is how many crashes occurred on this section of highway, and then you can symbolize based on whether it's high number or low number. And so the areas in red are areas undivided by rest areas or cities that had a high amount of fatigued crashes occur in the years between 2013 and 2017. And here's the model for that. I think I showed you that already. So, and on to my final product for the site selection. On the left is the proximity assessment, and then on the right is the density assessment. And it's actually kind of surprising how many crashes occur just kind of in the cities. Maybe it's not surprising, higher populations, but that's why you see so many of the pink line there near where there's cities, because where there's cities, there's people driving, and so it just kind of makes more sense. But what I did with these two rasters, I reclassified them for the rasters to have a 1. Each pixel would have a 1 where it was considered a high density area, or where it was considered a area far from opportunities for rest, and then no data everywhere else. And then I used the weighted sum tool to find where those 1s overlap. And so in the final output, you're either going to get a 1 0, not a 1 0, a 1 no data, a 1 no data, or a 1 and a 1. And so you're just going to get a bunch of 1s and 2s. And everywhere where there's a 2 is where I determined the criteria was met for an ideal site selection, for an ideal site for a new crash area. And in my project boundary is just in this little area on the west end of Lane County, south of Benton. I blew it up on the right side here. It's like, you perform this analysis, and all I really got was this area over here. And what that tells is either my criteria is questionable, which is very likely, or it's just kind of a safe area. There's really, they've established rest areas at good locations. Yeah, this is what I got. So for vulnerable areas along Highway 36 and Highway 126 headed to the coast, there's a couple areas where if you're tired, it's gonna be tough to find a place to rest, and you're probably gonna be with good company of people who have had a crash there because they were tired. And that's all. So yeah, thank you for listening. I'd be happy to explain anything or answer questions if anybody would like to reach out to me at my email there. Or if you're pursuing a career in GIS, you can connect with me on LinkedIn. And networking is always good, so I'm all game for that. And thank you, and I hope that you enjoy the rest or your time off between semesters or quarters or whatever we take. All right, thank you.